In today's class, we are going to show that every field is an integral domain. So let us start with the field f. So I will say let f be a field. But what is a field? Field is nothing but a commutative ring with unity in which every non-zero element is a unit. So I will say now to prove that f is an integral domain. Means what? We have to show f is a commutative ring with unity without zero divisors. But as we can observe, since f is a field, f is already a commutative ring with unity, isn't it? So the main condition that we have to show is that f is without zero divisors. So as I told earlier, we have to prove that f is an integral domain. But in order to prove f is an integral domain, we have to show that f is a commutative ring with unity without zero divisors, but f is already a commutative ring with unity, thus it remains to show that f is without zero divisors. But what is the condition of without zero divisors? You take two elements of the ring f, let us say AB, such that A multiplied by B is equal to 0, and you should be able to prove A is equal to 0 or B is equal to 0. Then we say that the ring is without zero divisors. So here I will do the same thing. I will start with two elements AB in F such that AB is equal to 0. Now our claim is to show A is equal to 0 or B is equal to 0. But let us say if value of A is 0, then we are through, isn't it? Because we have to show A is equal to 0 or B is equal to 0. If A is equal to 0, then we are through. So now let us assume if A is non-zero and let us see what happens. Assume that A is non-zero. Remember, we wanted to prove A is equal to 0 or B is equal to 0, but right now we are assuming A is non-zero, so it becomes compulsory now to show that B is equal to 0. Now our ultimate aim is to show B is equal to 0. Let us call it as some star. Now since A is non-zero, but f is a field, right? And according to definition of field, every non-zero element is a unit, right? So this will imply A is a unit in F. What is the meaning of it? Unit means we will be able to find a number A inverse in F such that A into A inverse will be equal to 1. So I will say this implies there exists A inverse belongs to F such that A into A inverse is actually equal to 1, and we will call it as some double star. Let us say now from star what we are having, AB is equal to 0, right? Can you guess what should I write now? What should be my next step? I will actually pre-multiply by A inverse. So I will say pre-multiply by A inverse, which implies A inverse into AB will be equal to A inverse into 0, which further implies now we will use the associative property in ring. So this is same as A inverse A into B is actually equal to 0. But what is A inverse A? It is 1, right? From double star. So this implies 1B is actually equal to 0 using double star. But what is 1 multiplied by B? That is B, right? So this implies B is equal to 0. And remember that 1 is unity and thus 1 multiplied by p is actually p. So what actually we have shown is, thus AB belongs to F such that AB is equal to 0 actually implies A is equal to 0 or B is equal to 0, and therefore F is without 0 divisors, and therefore F is an integral domain. So that's all for today.